afternoon, good evening, depending on from where you are joining us. Today is 2nd March 2024, which marked the first PSI 2024 first quarter webinar. And today we are having a very renowned and experienced researcher that will take us through another important aspect of the research, which I'm very sure is new to many of us. And even to those who are experienced, there's a lot of things that I'm very sure they will learn from her vast knowledge and experience. So as we all know, Pharmacy Scholars Initiatives, we do provide, or we do conduct bi-weekly webinars. And then after every 3 months, we invite an international experts to discuss or to share knowledge with us about research, career development, and any other self opportunities. And before we venture into the main business of the day, I will invite Dr. Mustafa to give us a brief overview of who PSI is and what we do. And before we, hello? Yes, continue, yeah, Mustafa, sorry. So before we give an overview, let me just make an announcement. Okay, I think there is some confusion here. All right, Mustafa, continue.
All right, so thank you so much, Dr. Ibrahim Jato, for this opportunity. First and foremost, my name is Mustafa Mohammed from University Science Malaysia. Normally, we try as much as possible to give some brief regarding who we are as a platform. The platform is Pharmacy Scholars Initiative. So we believe that there are audience among us that are attending the presentation for the first time. So would appreciate to share some of the information relating to our platform to them. So the platform is mostly has to do with mentorship network for pharmacists and other scientists who have some kind of keen interest in research and career development. So it's like a platform that has to do with some sort of mentor-mentee research relationship where we have some senior mentors that mentors some mentees in terms of research, talking about conceptualization of the research, the conduction of the research, data collection, analysis, and even writing. And I can tell you, the platform has benefited quite a lot of members from inception. We actually founded in 2017. So you can imagine, since 2017 until now, we've been involved in quite a number of research activities and a lot of publications came out of this collaboration. So just to make ourselves like a legal entity, we'll be registered with the Corporate Affairs Commission, that's in Nigeria, and we have quite a number of members cutting across various countries all over the world. So, good, next slide, please. Just some couple of announcements. We are going to record this session. So at the end of the day, members who need to have some copy of the recording will have access to, will send through your emails. And then that will allow our guest speaker, very important, to take her time to discuss the topic without any form of interference, unless if she so wish. And then we are going to share our emails where if you have any feedback, you can send us feedback. And at the end of the session, we'll open it for question and answer session. So next slide. So today's webinar is going to be on data science in research. We have one of our learned scholar, Dr. Olive Schmid from Royal Hobart Hospital, Tasmania, Australia, who is here with us. You are most welcome, Doctor.
Hello, lovely to be here.
Yeah, you're most welcome. We're happy to have you here. So the session is going to be moderated actually by one of our own, Dr. Abubakar Ibrahim Jato. So this is just briefly the agenda for today. We'll have some kind of citation of our guest speaker, which is going to be done by Dr. Ibrahim Jato, I believe. And then our speaker will have some like 30 minutes, depending, I'm not sure how long, of her presentation on the data science and research. Then we are going to open the session for questions and answers, and then we wrap it up with a closing remark. So without further ado, I would like to invite Dr. Ibrahim Jato to continue with managing the session.
All right,
Thank
thank you
you.
so much, Dr. Work, Dr. Mustafa, for this brief intro. All right, so as we have been doing this for the past 6 years, starting in December 2017, and today, 2nd March 2024, we are witnessing yet another very important and relevant webinar. And I'm glad to inform you that our special guest speaker today is Dr. Olive. And Dr. Olive has a very vast knowledge and experience in research, especially clinical research involving data entangling, data management, analysis, and presentation. She works with Royal Hobart Hospital in Hobart, Tasmania, in beautiful country of and continent of Australia. Who is Dr. Olive? So Olive graduated with a PhD from the University of Tasmania. I would say I'll add to that, like from prestigious University of Tasmania, Australia, in 2023. That's the last year. So that means she's fresh, as you see. And her PhD investigated recurrent hospital admission associated with adverse drug reactions in Tasmania, Australia. And I know what she went through, dealing with a lot of data and complex research and data management. Her research utilized longitudinal administrative data from Tasmanian public hospitals. And previously and currently, she works as a clinical research officer at the Royal Hobart Hospital. And her role includes coordinating data and biospecimen collection and research governance approvals for oncology clinical trials. And this is one of the major responsibilities she's doing, in addition to other research responsibility at the hospital. Previously, or before joining the University of Tasmania or Royal Hobart Hospital, Dr. Olive, she was previously managed a large-scale epidemiological study for Cancer Council Victoria. I'm very sure most of us are not familiar with Victoria. We only know Melbourne. So Melbourne is the capital of Victoria. So, and anybody who knows, sorry, Melbourne is one of the biggest, I think it's the second largest, biggest city in Australia. So managing large-scale epidemiological study involving people living with cancer will tell you how big the data is and what the work that Dr. Oli puts into it. And then in this role, she was responsible for obtaining Human Research Ethics Committee approval for study protocols, recruiting participants, and coordinating the administration of study questionnaires. And today, we invited Dr. Olive to share her experience with us on data science and research. As you all know, we are all, anybody who is involved in conducting research, except if you are doing some social sciences or even clinical research, possibly if you are dealing with literature review. But if you're into original research, that's conducting primary research, you will definitely have to do with data. So data sourcing, data management, data analysis, presentation is one of the, you will never ever go away with it while you are conducting such kind of research. So it is something that is very, very important for all of us to listen and learn something new that will definitely assist us in conducting research, understanding research, and making knowledge out of our research. And today, I welcome Dr. Olive from Royal Hobart Hospital to share her knowledge with us on this PSI first quarter webinar 2024. Dr. Olive, you are highly welcome.
Okay, thank you for that lovely introduction, Dr. Ibrahim. Okay, I'm very happy to be here this evening or this morning, depending on where you are. And I will be talking about data science in research. Okay, we had some problems earlier this afternoon with sharing the screen, but I think we are an intelligent team here running the Pharmacy Scholars Initiative. So I hope that we can get this screen sharing of my slides up and going without any problems. Okay, are we good to go?
Yes.
Yes, excellent. Everyone can hear me and see my slides?
Yes.
That would be a good start. Okay, so everybody knows who I am, I hope. And I was going to wear my lovely hat. It's been in the cupboard collecting dust since graduation day, but maybe I might wear it if I'm invited back for another presentation. Okay, so this evening I am talking about data science in research. So just a quick overview of my presentation. There'll be an introduction. I'll be talking about data science in research as a new frontier in obtaining new medical knowledge. I'll be presenting a case study and leaving you with some recommendations for data science in your own research. Okay, so the Data Camp blog, which is a good resource for data scientists, they have summarized data science as involving data collection, data preparation, exploration and visualization, experimentation and prediction, and finally, data storytelling and communication. So although a lot of the foundations of data science, such as these, also apply to traditional research methodologies, where researchers collect their own data for the primary purpose of conducting their research, data science also encapsulates the use of large data sets collected in the real world and usually originally collected for another purpose. So this necessitates a new breed of researcher with the technical acumen to manage these large swathes of data and utilize the rich information contained within them. So it's really harnessing, data science is really about harnessing all the available data sets in the world today with the advent of things like electronic medical records or electronic prescribing records, or even research subjects who might be using Fitbits or things like that, or continuous heart rate monitors, to collect a lot of data that researchers in the past might not have had access to. So data science can be defined as an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. In simpler terms, data science is about obtaining, processing, and analyzing data to gain insights for many purposes. A second definition of data science from the National Institute of Health Strategic Plan for Data Science in the US is the interdisciplinary field of inquiry in which quantitative and analytical approaches, processes, and systems are developed and used to extract knowledge and insights from increasingly large and/or complex sets of data. So hopefully those definitions can set the scene for the presentation this evening. Okay, so I wanted to just give a few examples of where data science has really utilized data sets to make some new, contribute new knowledge to medical research. So there's a study that identified drug cancer associations with a nationwide screening study. So this study looked at the long-term carcinogenic effect of new drugs, of the carcinogenic risk that was not identified in shorter-term clinical trials. Data science was used for infectious disease surveillance, and the importance of this really came through in the COVID-19 pandemic. Data science has been used to improve screening for aortic aneurysms and looking at the risk factors to be for frequent admissions to hospital in patients with heart failure. So all these different topics utilize the skills of data science. And just to emphasize that data science really is a new and exciting field, it's been described as the discipline of data science has emerged, flourished, and evolved rapidly over the last 20 years in lockstep with the rise of big data, artificial intelligence, machine learning, statistics, and inexpensive computing. And just to really emphasize this point that data science is a new and evolving field, I've just copied the graph. You might be familiar with these graphs when you do a search in PubMed, when it shows you the year of publication of any journal articles that come up in your search. So this was just looking for journal articles with data science in their title. And you can see just in the last 5 years that it's gone absolutely gangbusters. And it would be expected to continue to increase in the years to come. Okay, and now I'm on to a case study. And Dr. Ibrahim, I'm sure, would be surprised at how excited I was to be able to present some of my thesis findings as a case study in this presentation, because I think the hardbound copy of my thesis is collecting dust on my bookshelf. And I'm not sure how many people have actually read it, not even my mum and dad. But here we go. My thesis was titled Recurrent Adverse Drug Reaction Related Hospital Admissions, Prevalence, Patients, Predictors, and Presentations, which was a bit of a tongue twister for the Vice Chancellor to say on my graduation day, but he got there. Okay, so the objectives of my thesis are probably a little bit beyond the scope of the presentation today, but I just wanted to give you an idea of the sort of things I was looking at in my data set. So I was identifying risk factors for experiencing an adverse drug reaction, or ADR, related hospital admission within 90 days of discharge from an acute hospital admission. I compared the risk of an ADR-related admission for up to 5 years after discharge from an ADR versus non-ADR-related index admission. I assessed the proportion of ADR-related admissions that are experienced by patients with a previous ADR-related admission. I identified the drug classes associated with repeat ADR-related admissions, and I characterized the patients at risk of 2 or more ADR-related admissions within 12 months. And I think just from pointing out these objectives, you could imagine the amount of data analysis that was required for my PhD. And basically my whole PhD ended up just looking at the one data set to answer all of these questions. Okay, so the methodology for my research was that we conducted a retrospective cohort study based on Tasmanian Public Hospital's Admitted Patient Care National Minimum Data Set. So we extracted approximately 6 years of data that was mandatory for public hospitals in Tasmania to maintain these data sets. And that contributed to their different funding and things like that, and to track increases in patient admissions or the type of care that patients needed while they were admitted, and things like that. And the data set used the ICD-10 diagnostic codes. And just if you're not clear, it was actually ICD-10 AM codes, which the AM means the Australian modification of the ICD system. So this data set that I used contained approximately 200,000 acute admission records and 90,000 patients. So in a nutshell, and it looks 3 easy steps here, but I can assure you that that was not the case. I extracted the government mandated hospital data from the admitted patient care minimum data set. I identified adult patients with an acute overnight admission between 2011 and 2015. Then I tracked subsequent admissions for a minimum of 17 months per patient. And then I'm not sure, sorry. Okay, then I'm not sure if you can read this on the slide, but if you're interested, you can have a look when the slides get emailed to you afterwards. My thesis really consisted of 3 sub-studies, and I've just got a little flowchart here of each study just to show that I was what I was looking at to give you an idea of the data preparation that I needed. Okay, now we get into the real data science of my research. So when I received the data extract from the data custodian, there are a few steps that I had to do. I identified and addressed any outliers and anomalies in the data. I developed and applied rules for coding new variables. So this would be using things like the ICD codes that might correspond to classifying someone as having diabetes, or classifying someone as having cerebrovascular disease, or things like that. You could come up with different rules for how we wanted to define different conditions for my project. I developed criteria for selecting eligible subjects and events, and that included how to identify acute admissions in the data, and that meant excluding admissions that were for things like obstetrics or dialysis, because we thought they were not really part of the objectives for my study, but were included in the hospital data sets. I developed some reference data sets to facilitate the statistical analyses. I performed statistical analyses, including descriptive stats, logistic regression, and survival analysis. And then the fun part of the research was presenting the findings in novel graphical formats for publications and presentations. I identified major trends and communicated the study findings. And voila, I had a PhD. Okay, but really getting the PhD was not as easy as that, because the raw data that I received from the hospital data custodians was not, because it was collected for the hospital and it wasn't something that I collected and entered into a database for the purposes of my research. It actually facilitated, it was not in a form that facilitated the required data analysis. So substantial preparatory data wrangling needed to be undertaken before the stats could be conducted. So it wasn't like I received the raw data and could just run some logistic regression in SPSS or Stata or any of the other statistical software that researchers often use. So this data wrangling involved cleaning the data, restructuring it, and enriching the raw data. So this was a completely different approach to research than Dr. Ibrahim, who I shared an office with in our PhDs, because while he was off traveling around the beautiful state of Tasmania, recruiting subjects for his research and measuring their blood pressure and conducting questionnaires, I was trying to untangle a data set that I had no idea really what was going on with it at the start, and also no idea about data science. But I've come a long way since then, and so I'm happy to share some of the things I learned along the way. Okay, so one important step in the data wrangling that I did was each patient in the data set could have up to 100 diagnosis ICD codes recorded for each hospital admission they had. And so each of those codes, up to 100 codes, needed to be cross-checked with 253 ICD codes that represented an adverse drug reaction. So as you can see, even from this visual representation, that is a crazy amount of data programming to try and unravel whether an admission was associated with an ADR. And it's probably beyond the scope of this talk to show the coding that I used to do this, but I'm just pointing out the complexity that can, the complexity in utilizing data that was not collected for your the primary purpose of your research. Okay. And some more data wrangling that I had to do before I could plug my my reformatted data sets into some statistical programs was to convert the ADR data from long form, where each ADR code comprised a unique row in the data set. And then I restructured this data so that each ADR code could be treated as a unique variable. So you might be familiar with when you run logistic regression, that really for each subject, each variable really needs to say yes or no. Did the patient have this condition or not, or what, you know, what was their age range, or there needs to be a new field for each variable in the regression. So it might make more sense if I flick to the next slide, where you can see in the raw data, in the first table, you can see that each ADR that a patient had is recorded in a different row of the data. But really, to do any meaningful analysis, we had to transpose that data. And in data science terms, that means converting it from long data set, which is a long column of data, into a wide data set where it goes across the page. Each different ADR gets its own column, and then a 1 or a 0, depending if the patient had an ADR associated with that medication class. So some aspects of data science are really thinking about how you need your raw data to look to actually enable you to run some stats. So it's a lot of preliminary work thinking about what you need for your statistical analysis. And again, the programming code to do this data manipulation is probably beyond the scope of this presentation. Okay, and probably what I thought was the exciting part of data science is the data visualization, when you can make lots of pretty graphs to show the major findings from the data. And this was a graph that, unfortunately, it didn't make the final version of my thesis, so I'm happy to show it here today. And I'm not sure if you can read it on the slide, but if you get emailed the slides later, you might have a better look. Down the x-axis, we've got a list of drug classes that were associated with ADR admissions. And then on the y-axis, we've got the symptoms that are commonly associated with ADRs. Now, the problem with my data is that we weren't directly capturing cause and effect. So we didn't know exactly what symptoms were considered related to the ADR when the patient was admitted to hospital. But just going by common sense and knowledge of different drugs and their side effects, and also just by the numbers of patients that we had in this data set, you could see some trends emerging. And that's why I think this graph is a really good way to show that not everything can be measured with proportions or with p-values or with logistic regression, but this graph just shows some associations which could be hypothesis generating to look in more detail about what's going on. So I know that one finding here that really jumped out was in the second last row, which is opioids. And if you scroll across to the yellow circle for GI symptoms, you could see there were 209 admissions where an opioid-related adverse drug reaction was related to GI symptoms. And that was a fairly, in the context of the study, when you can see there were 400 admissions with antihypertensives and blood pressure effects, which would be expected. When you look at the GI symptoms and opioids, it can make you wonder whether they were preventable or what better care of the patients could avoid these hospital admissions, because patients shouldn't be getting admitted routinely for digestive problems from the use of opioids. So I'll leave that slide for the moment. And I thought it's not all a bed of roses using administrative data like I did in clinical research. And I thought it was just worth pointing out some pros and cons of using a large longitudinal data set, because obviously the data set was not designed for my PhD. So there were good and bad things about using it. But we adopted this data set for this research based on its utility to support my study's overarching aims and objectives. And I'm not sure if people in the audience are familiar with performing medical chart review to identify adverse drug reactions, but that methodology would identify ADRs at a higher rate than using administrative data sets and the ICD coding. And direct chart review could probably better elucidate the causative medications in an ADR. But this was not a feasible strategy for the long-term follow-up of a large patient cohort. So obviously in my data set where we had 200,000 admissions, 90,000 patients, and about 5 years of data, it's not feasible to have someone standing at the front door of the hospital collecting data from every patient that comes in for 5 years. So we needed to make some accommodations to make the best use of this data that we could. So the pros of using this data set were that it was readily available, inexpensive, and provided population-level health data. The ICD-10 codes assigned for ADR-related hospitalizations have been found to accurately reflect the ADR as found in the medical record in the majority of cases. The person hours required are minimal when compared with the time invested in ADR detection based on chart review. The data was systematically collected over time. Additional clinical and demographic information was included. Another important point was that the follow-up of individual patients in this large data set did not require their active participation and as such, informed consent was not required. So if you were actively following up patients for 5 years, you would expect a proportion would be lost to follow-up or start ignoring your mail-outs of questionnaires or your phone calls or things like that. But because this was not an issue for my study. And the hospital level administrative data captured a large number of patients and a large volume of admissions over the long term. So this provided meaningful and robust statistical analyses with the capacity for the results to reach statistical significance. And some of these things are really hard to obtain if you're doing a small scale study of your own, of actively recruiting your own patients and following them up. It's not really feasible. However, the cons of using this administrative data was that the recording of the external cause codes, which were the ICD codes that flagged an ADR, they could be compromised if multiple medications were used or multiple medications were attributed to the ADR. It could be difficult to untangle what was going on. The external cause codes identified a medicine class rather than a specific medicine. So it might say, for example, an antihypertensive caused the ADR, but it wouldn't say which one or which type. And concomitant medicine use, which may have contributed to the propagation of the ADR, was also not recorded. So as you can see, and it's sometimes I think it actually was a bit ridiculous that I did this whole thesis on adverse drug reactions without knowing a lot of detail about the actual medications that patients had been taking. But also that shows, it also shows that the potential growth in data science, where the data set I used from the hospital could possibly have been linked to other pharmaceutical records in Tasmania or government prescribing records kept by the health department in Australia. But that was really beyond the scope of my PhD, because doing data linkage like that and getting ethics approval for that research I'd probably still be doing my PhD today if I tried to do those things, even though it really would have added a lot to my thesis, but I couldn't answer everything if I wanted to ever graduate. Okay, so I wanted to just share my recommendations after doing such a PhD that was so intense in the data science side of things. I would recommend that you use the R software for all your data science needs. So I'm not sure if everyone has heard of R, but it's designed to handle large data sets, to be reproducible, and to create detailed and customized visualizations of your data. It's open source, so if your uni or institution doesn't have a lot of money for fancy statistical software, R is your answer. It supports easy data wrangling. It has powerful graphics capability. So really, it's not just like in Excel, where there's not a lot of control over the sort of graphs that will produce from your spreadsheet. For R, you can really get creative with how you want to present your data, and there's lots of different options. Another important thing about R is that it facilitates reproducible research. So it's really easy to share your code with other researchers. And also, if you wanted to run the same analyses a few years down the track to see if the results had changed or there'd been improvements or there were other patterns showing up, you could basically run the same code again with updated data without a lot of without reinventing the wheel and writing your code again. And something else I found with R was I hadn't used it before my PhD, and it was a fairly steep learning curve at the beginning, I have to admit. It was like learning a foreign language amongst all the stress of doing your PhD. But there's a really, and I think because it's open source, anybody can write code for R. And so there's a really supportive online community where you could often find answers to any questions you might have or things that you were stuck with or trying to troubleshoot. So I found that really a really good resource. Okay, so this might just be something you can look at after today's presentation, but I thought I would just give a quick overview of how to install R, because I know everyone will be keen after my presentation. I'm sure this is the first thing that you're going to do. So I've got the address of rproject.org there. And you can download and install the R software by clicking on the link on the left-hand menu to the Comprehensive R Archive Network, or CRAN website. And you can see in that screenshot of the web page, you can see on the left-hand side where it says download and CRAN. If you can click there to download the program, you'll be prompted to select a CRAN mirror. I'm not quite familiar what this is all about, but the mirrors are basically different servers located in different locations which host different R packages for you to download. And I would also suggest that you install RStudio, which is software that makes operating R programming a bit easier. It's just an easy way to manage all your code and associated data. So I hope that might be helpful if you want to try to use R for any of your research. Also, as I mentioned previously, R is really amazing at making lots of pretty graphs. So I've just given some examples here. I can't take credit for them, but they're the sorts of graphs that you can make with R. And I've given the link here to the R graph gallery, which is full of all sorts of graphs that you can make in R. So sometimes you can just be, you might be stuck of how to present some of your results or some of your data. So I found that graph gallery really helpful to try and think of the best way to present the findings of my research. And also it would help with the code that you could use to produce some of these masterpieces. And another, this is another resource that I thought you might find useful if you start using R for your research. It's called the Stack Overflow website, and I've got the link there. And really, it's like social media for data nerds. So you can type in really any question that you might have of something that you're trying to do, and you can just see mostly it's a question that's been asked before, and there's been lots of helpful data nerds on Stack Overflow who have been more than happy to help answer these questions. So as an example, you might see at the top there, I've searched long to wide in R, and then these are all different answers that came up of how to address that data manipulation. And if you can't, you can't find an answer to your question, you can even post your own code and ask for help in making it work. So that that resource is invaluable, especially if you're new to using R or to data science. Okay, and this is my last little bit of my presentation. I just wanted to show R in action, so to see what it does. So this is a big chunk of code that I wrote for my analysis. And in the end, the code actually produced a really cool graph. So I've just made a screenshot of doing its thing. So let's just watch here. Running all the code, and R's doing lots of data manipulation in the background, lots of coding and data cleaning. And voila, here is a pretty graph of showing ADR survival after an ADR and non-ADR admission. And just from watching that, rerunning that code, you can see that if I did a mistake early on the code, it's so easily fixed. And then I can run the code again just if I fixed up a mistake in the first or second line. It doesn't mean you have to go back and repeat a whole lot of work. Or some other things that I found are really helpful for was working out the most appropriate age brackets to use in my research. And so I could run the same code and make the same graphs, but just, you know, maybe having the age cut off at 65 instead of 70 or 85 instead of 90. And you could do the same analysis and make the same graph, just with a few really quick tweaks to the code. You could have a whole new data set. So that's some other advantage of R. And that is all. I hope
Wow, thank you very much, Dr.
helpful.
Olive. Yeah, we really appreciate your time and for sharing your knowledge and experience with us. I'm very sure we have learned a lot from your vast experience and knowledge. Before Dr. Olive, during her, maybe for those who joined lately, Dr. Olive has took us through the definition of data science, what data science is, and a broad overview of the whole idea about data science. And she used her PhD research to demonstrate like a case study about how or the application of data science in research. And going through, she also mentioned the pros and cons of using data science, of using large data from administrative data set, if I'm correct, Olive.
That's correct. You've been paying
attention. Exactly, yes. And how you can manipulate the data to generate a lot of visualizations where you can interpret the data and make sense out of it. And before going to questions and answer session, I would like to start with my question. Possibly maybe it has been skipped during the lectures, or the audience might like to ask. Number one, Dr. Olive, what's the pros and cons you gave us? It's like a general thing. So during your PhD, what are the challenges you faced with all this data management, data wrangling, and the whole experience with the data? Is there any like a common challenges you faced? And that's number one. And number two, for us that we normally go to the field, collect data from face-to-face interviews or from an online survey, one of the tricky things we normally encounter is missing values. I'm sure Dr. Mustafa Dr. Mustafa is his field. So we always have issues with missing values, and when you come for analysis, sometimes it is really difficult to handle them. In fact, I could remember during my PhD, we had a lot of issues with Professor Greg and on how we can handle missing values. And so I'm not sure if dealing with large data like yours also involve like challenges related to missing values or something related to that. Finally, it seems like you are very expert now on this data thing. Did you attend a separate training in data science in addition to your big PhD courses? Or I know we did graduate research certificate, so I'm not sure if it was part of your certificate. And the reason why I asked this question to guide our audience that if they want to really be experts in data science, because I know there are a lot of opportunity when you finish your PhD or master's or your certification. There is a lot of opportunity with data science, and most of the beauty about it is sometimes you don't even have to go to the office to work in data science space. So it's something that you can do at home and you'll be paid fully. So it's something that I really encourage us to go into it. So going back to my questions, Dr. Olive, are there any challenges that you faced?
Okay,
That's
so
and any missing values, and then any separate training you receive or not? Thank you.
okay, so the challenges. I could talk about this for days, the challenges, because I really did have some big challenges at the start of this data analysis. And as I mentioned, our friend here, Dr. Ibrahim, it felt to me that he was on a holiday traveling around Tasmania, seeing all the beautiful scenery, beautiful national parks and beaches and mountains and country towns. And I was stuck in the office.
Yes.
I remember the first time I received my raw data and I couldn't even work out how to upload it into R. So the very first thing that I had to do to upload the data to even have a first look at it, I was stuck. So there were definitely challenges, and I would definitely say that there's a steep learning curve when you start using R for the first time. And to answer Dr. Ibrahim's question, I did a very introductory statistics course at the start of my PhD, but that was just the very, very basics of R and the syntax used, but it didn't come anywhere near to teaching me the skills I needed to analyze my data. And so basically, I taught myself different tricks or different functions in R just from Google, from statistical textbooks, and a lot from the Stack Overflow website that I mentioned previously. It was such a big, big help to try and do things. But one thing I would mention, even though R does have a lot of challenges at the beginning and it can feel overwhelming, once you get the hang of it and you understand the language and the syntax and, you know, when you need inverted commas or brackets or what's the function and commands and how to read the code, you can actually be set for really bigger and better things with your data analysis and data management. And you can build on other people's increasingly complex code and customize it for what you might want to do once you have an understanding of the basic fundamentals of how it works. But absolutely, I think anyone using R for the first time would find it a challenge. Okay, the second question was,
how do you address missing values?
The missing values. Okay, so one thing with using administrative data or data that's been collected by another organization or for another purpose is that you, at some point, you need to have some level of confidence that the data is mostly legitimate and reliable. So you can't go back and check every value to make sure that it wasn't a typo or a data entry mistake. So that's why with the hospital data we used, we know that the hospital is audited, that they are entering the data correctly. So there are some checks and balances before we receive the data. So hopefully, and we know that the clinical coders at the hospital who enter the data initially, that they are very qualified and experienced and following pretty strict protocols for how to code different admissions and different diseases. But there's always going to be outliers or anomalies in the data or missing values. But I think I did have to make some decisions of what to do with this. Sorry, this isn't quite directly answering your question, but it kind of relates to it. In you know, sometimes you could see things that were obviously a mistake, like if someone's date of birth was, 150 years ago, or they were in hospital for 3 years, or, someone gave birth when they were 65, something like that. You might think, okay, we can clean that data and just delete those records. The advantage of using such a big data set with our 200,000 admissions and 90,000 patients was that hopefully it would, any missing values would kind of be compensated for and not affect the final results, because it was such a rich source of information with so many patients that if there were a few missing values, it really wasn't a problem.
All right. Thank you so much, Dr. Olive. Yes, I really appreciate your answers.
So
all right, let's go.
Sorry,
Let's go to the flow.
could I just add one more thing?
Okay.
Sorry,
No, I'm fine.
Just with the missing values,
Yes.
when we were collecting information about the patient's medical conditions at the time of their admission to hospital, we couldn't actually tell what was missing, because if a patient had diabetes and it wasn't recorded, well, we didn't know that that diagnosis was actually missing. So that again comes down to having to have some faith that the data was collected comprehensively.
Oh, okay. All right. Thank you so much, Olive. I'm sure we all understand the answers given to the questions. All right, let's go to the floor. I'll start with Dr. Mustafa.
All right. Thank you so much, Dr. Olive, for this insightful presentation. I believe for some of us that have conducted studies that are almost related to what you just presented, we are really inspired. And then before I go into my question, just one short note, like if you are given the opportunity to redo another PhD, will you rather go for a prospective-based study like the one Dr. Jato did, screening patients in the field, or still go back to the registry form of retrospective study? This is very important because I notice there is this argument. For us that I used a stroke registry in Malaysia for my study. This is a registry of over, I think, 200,000 patients. But then at the end, I was able to just use less than 20,000 for my study. So people used to think that those kind of study are easy because you've already have data at your disposal. Like especially when they are doing prospective study in the field, they feel like, oh, you already have data. We have to source our data. So what do you like? I just want to take your brain on this because it's a question that I receive quite a number of times.
Yes, it's an excellent question, and I'm sure that when I was jealous of Dr. Ibrahim touring around Tasmania, he probably was jealous of me just having a data set given to me without worrying about finding participants. So I know the grass is always greener, is what everyone would think, that their PhD seems the hardest. And every PhD, every research project has its own challenges. The piece of advice that I would have is that if you are embarking on a research project that is using a large longitudinal data set, administrative data, registry. I think and if it's for a PhD, the PhD supervisors, as well as the student, need to be really aware of the amount of work that might be needed before you can start spitting out some meaningful results. Because I know, like, we were just kind of joking that, Ibrahim could look at my data and think, oh, it was just given to me. But that did not mean that I could start doing analysis. And I know for the first, 6 months of my PhD, some of my supervisors were a little bit, I think, disappointed or confused as to why it was taking me so long before I could even start pumping out any results. But by the end of it, they had figured out just how much work was involved in the setup of organizing the data to be in a format where we could do the analysis. So I think it's not that one, that collecting data in the field versus using an existing data set, it's not like one is better than the other, but I think you just have to know what you're in for and know how much time it will take or what skills might be needed, or really what best fits your research question and your timelines.
Yeah, exactly. I also go with your own point, because there are quite a lot of things that happens when you have data, especially the wrangling of the data you're talking about. I could recall it takes me almost more than a year to figure out how to handle those kind of data. So you can imagine.
Absolutely.
And then some of those things you cannot practically modify anything, the
That's
objective
right.
of your study come after the data has already been extracted. So there is nothing that can be done in terms of correcting the data set itself when it comes to getting in line with your study objective, something like that. So it's a tough work. Then secondly, I would like to also ask, how big do you consider a data? Because we're talking about big data. As in, is there any limit to what you can call this big data? Then lastly, I would like Dr. Olive, out of her busy schedule, to please find time in the future to give us some hands-on application of R in this same field that you presented. We really appreciate this. Thank you.
Okay.
Mm.
Sorry, could you please just repeat the question again?
How big do you consider it a data as big data?
Oh, okay.
Is
So
it 10,000?
in terms of how many records or patients or admissions would be a big data set?
Yeah, something like that. So maybe, for example, do you consider somebody that has treated, what I understand is some of these softwares, they are like R starter, can actually practically handle quite a lot of big information. Like for me, when I started running my data analysis, I used SPSS. And then sometimes SPSS hooked, as in it cannot even proceed in processing anything. So you can imagine.
Okay.
And this is a data that is just, I think, 10,000 or thereabout. So I believe maybe when somebody has a record around 10,000 patients, then multiple of that for variables or the data set, I think we could be able to consider it as a big data. And then you need some of these powerful tools like the R starter to be able to handle them properly.
Yes. So I'm not sure what the limit is for other statistical programs like SPSS. I'm not sure how many records they can handle. But I also know with R, it's not so much as the R program, but sometimes I exceeded the memory on my laptop. So sometimes some of my code could not be run on the whole data set at once because my laptop did not have the required power. So sometimes then I split things into maybe old patients and young patients, or males and females, and I ran a whole bit of code, a whole chunk of code, and then I would join the data sets together at the end. But I think that's more about your computer capability than the program. Yeah, I'm not really I'm not familiar with all those sort of technical aspects of like, the
Okay, I would say you data scientist, it's better for you to give a yardstick. I mean, data set of 1,000, 2,000 is considered as large. Otherwise, me with 1,700 data sets, I would say I'm dealing with large data sets.
Enough. We are dealing with enough. Yeah, I think that's pretty good. I really appreciate it. So we still have to go with the capacity of the computer and, of course, the softwares that should be able to handle quite a big chunk of data, like the R you're talking about. Yeah.
Yeah, because I do remember near the start of my PhD, there was talk that maybe the university would invest in a better computer for me, but then we realized it didn't really come under the budget, so we had to try some other tricks. Yeah.
All right, thank you so much, Dr. Olive, for answering these questions. And just to add what Dr. Olive said, and to share with people who just joined us a little bit lately, Dr. Olive shared her knowledge about data science, and she used her PhD as a case study to teach us about how to handle data, how to the data wrangling, management, visualization, and how you can play around data to give you your desired result, and not desired result, sorry, your objectives, because the result might not be what you desired from the beginning. Yes, and again, she also shares some resources that we can go through, especially for some of us who might want to use the R software. So she gave us the link where we can download the software, and then the online resources where we can learn about it, and then also the online support group where we can get some help. Any more questions before we proceed to the next item on the agenda? Any questions on the data management, data used in research before? And at the end, we are going to share the link to this recording, your email, your certificate of participation. We are going to send it to your email address. We have already shared the link where you can provide your name, your email address, and then how you want the name, how you want it to appear on your certificate. So at the end of the webinar, we'll send you the link to the recording, and then your certificate, and then the slides for the lecture. And then when you have them in your inbox, if you go through them, if there's any question related to the resources, you can reply through the email. And before going to the next, I'll call Nuruddin. Nuruddin is senior lecturer at Usman Danfodio University. And he's the, I think, chairman, Clinical Pharmacy Association of Nigeria, Sokoto State. Mr. Nuruddin. Mr. Nuruddin?
Oh, okay. Can you hear me?
Yes, we can hear you now.
Thank you very much, and thank you very much, Dr. Olive, for this, let me say, provocative presentation. Very, very much indeed. When you talk about data science, especially the way you have presented it, it's actually a world in itself. Before going into PhD, some of us look at data, especially a very small data, as something very simple to handle. But at the end of it all, we realize that working for to gather or get information in form of data is is probably much more easier than even handling the data, because by the time you go through 1 year, 2 years, or a number of months putting down information in form of data, and after you put all the data together, you come back to look at the data, then the data becomes actually scary. But my question, especially with the kind of recommendation you give about the R, which I'm not very familiar with, is that when I look at all the presentation and the flexibility and the wrangling, specifically the syntax aspect, and I look at the one I am much more familiar with, which is the SPSS package, I don't seem to see any actually difference. I don't know, probably in terms of capacity to handle data, because most of the things I see in terms of wrangling of data, which probably you have to find a way to make the software do the wrangling, because when you talk about cleaning, rearrangement, and everything about the data, you do that all through the SPSS. And of course, the presentation in terms of visualization is also possible through the SPSS. And one thing I don't even know through the R data is in terms
Sorry, we've lost you there,
of data
Nuruddin.
categorization. Yeah, does it in terms of scale? Am I audible?
Yes, but it's a bit
Hello?
breaking.
I think it's good. Mm.
Okay,
Yeah,
probably I have.
Could you
I'm not sure.
type in your question, Nuruddin, because you keep dropping out.
I think what he's trying.
Oh,
I think what he's trying.
go on. Probably you have gotten what I'm trying to say. Just go ahead.
Okay, Olive, I think what he's trying to say is that he's trying to, based on what I understand and what picked from what he's saying, is he's trying to see is there any clear uh, benefit or advantage of using R over SPSS. I mean,
Yeah,
if I understand, Mustafa, is that what he's trying to say?
yeah, that was the gist of what I
That is it.
Yes.
Mm. Yeah,
I would say that considering the steep learning curve for R, if you're not familiar with it, and if SPSS can do everything that you need, well, then you're good to go. I think you would use R for there was lots of parts of the data wrangling that I did in my research that SPSS did not have the capability to do, and especially to rerun the analysis when we wanted to change one little thing or one little criteria without having to basically start again. That was a really good advantage for R. But if SPSS can make the graphs that you need and do the analysis and the wrangling that you need, then absolutely go right ahead. Because I would say to put in all the time to really become proficient at R, it's probably only worth it if you're going to use R for some pretty hardcore analysis.
Yeah, thank you so much. To add with Olive's, because in our space, there are some who use SPSS and there are some PhD students who use R. And to be candid, SPSS, yes, is good for the basic analysis and like especially for like small scale research. But if you are dealing with a very large data set like national or like a regional data set, I will really strongly encourage you to use R because the capacity of SPSS to deal with large data sets is a little bit limited compared with R. And R and Starter, and it doesn't involve complex step like in SPSS from here to here. In R, it's just use of code, a comma plus stop, some slash slash XX, boom, it will, it will just give you the table, the sketch, the everything, just a matter of a click. So it's good to diversify. I mean, to be expert in all the statistical software in case if you tried this one, it didn't work out, and you have the capability to to switch to wherever that is available. And yes, so in addition, another announcement, sorry, before asking for more questions, is there have been so many calls from our interested members to join our forum, and I'm glad to inform you that we have created PSI community where you can join and share your knowledge, participate in a discussion, and also learn a lot about research and what we are doing. And I think the link to the PSI community has been posted on the chat box. So if you would like to join, it's just a matter of click. You can click the link and join the community where you can participate in discussions. And in that community, you also post some career opportunities like PhD opportunities and many other things. And you can learn about research and so many announcements related to what we are doing. I would strongly encourage our people who are keen to join our activities to click this link and join our activity. So any more question? Is there any question in the chat box? I think
Yeah, there is one question.
I think there's one from Balarabe Urotu. He thanked the presenter for insightful presentation. And his question is, for someone who has never come across R, how does he start? And does it have any software manual as the case with SPSS? Before allowing Dr. Olive to say something, I think towards the end of the webinar, Dr. Olive has given us a link to R where you can find a lot of information about R, how to use it, and a community where you can ask answers or questions and get so many guidance from international experts. But I'll allow Olive to answer you as well. Olive, someone is asking.
Okay, yes, I've seen it here now popped up.
Yep.
Alarobi's question. That is a really good question. And I would say there's a lot of online resources that you can use that are easy to find just from Google. The issue with R is that it's open source. So that means that lots of different programmers from all over the world are constantly writing new functions and new capabilities for R. So it's not like everything can be in one manual like SPSS, because it doesn't have just one commercial developer. So that's why at the end of my presentation, when I talked about the CRAN website, that is a really good resource for all the different commands that you might use in R. And there's manuals for different functions that different programmers have written, and you'll easily be able to find help for just basic R commands there. And honestly, Google is your best friend. Just Google things like R for beginners or R basics or things like that, and you should come up with a wealth of information.
All right. So, Mr. Rotter, I think you have gotten your answer, and I'm sure you're convinced. So, any more? Let me see who is raising his hand. I think something Munir. Munir, you can go ahead. Okay, you say Ibrahim. Yep.
Hello, thank you, Dr. Olive, the moderator, and the other organizers. I have a question.
Okay, go right ahead.
Hello, please, can you hear me?
Hello,
Yes,
we can hear
we
you.
are with you.
Please ask your question.
Okay, it's regarding the R software, ma.
Right.
Like I know if we have used SPSS software before, so and I know you can use it for various analysis. But at the end, most at times, for you to present or visualize your data, I think you have to use some other software. So, but for this R, I don't know. It's like from your explanation, can you still use it to visualize your outputs after analysis, or it's just like the SPSS? When you finish, then you have to look for another software that you can use to visualize your output or results.
No, absolutely. One of ours best features is the
Yes.
visualization, and there is a lot of customization you can do, and it has a lot more powerful graphics than SPSS.
Oh, thank you. That's
But
good.
the downside is that what comes with better capability is that it's probably more complicated code to make your graphs. But once you get there, you can really make some beautiful, beautiful
Okay.
graphics.
That's good. Thank you very much.
No worries.
All right. I think that's the end of the question and answer session. Before presenting the certificate of appreciation to our special guest speaker, I've seen the the Haji Amina Omar, who is the Director of Pharmacy Council of Nigeria headquarters. And I would love Haja to say some words before we go to the next item. Haja, if if you can hear me, please. Haja Amina.
Yes, I can hear you clearly.
All right. So Haja Amina,
Um,
she is doctor. She has a PhD in pharmacology from Ahmadu Bello University, and she's currently a director at PSI head office, Abuja. Haja,
Good afternoon, everyone.
good afternoon.
I would just want to say some words of commendment and encouragement to PSI. I follow your programs a little bit as I'm chanced, and I really enjoy your programs and the knowledge. Like I've never encountered, I've never come across R before. So to me, it's really um, encouraging and important for us to be following such programs. We will definitely learn. I've learned a lot today, and I want to encourage you to do more. And I also want to encourage our young scholars to participate more in such activities. I want to commend the presenter, Dr. Olive, for a job well done. And I want to
Thank
say
you.
congratulations to you all. Thank you for giving me a chance to speak.
All right. Thank you so much, Ajia. We really appreciate. Dr. Olive, I think there are so many calls for this hour, and I think I really have to talk to you about organizing a hands-on training as requested by Dr. Mustafa. So I think the audience are asking if possibly if you can create another time for us to have like a full session where we be all with our laptops, we download the R, go through it, and then do some few basic analysis and data management just to have an idea of how we can use R. Then you give us, or we continue with the resources to continue learning. So, Olive, we hope our request is approved and granted.
Yes, I would be happy to help, because I
Oh,
really, despite all the headaches R gave me at the start, I am really, really passionate about it now, and it's like a religion for me to spread the knowledge.
all right. So our participant, I'll work out the date and the time with Olive about the date for the hands-on training on our software. And as usual, we share our invite through the social media platform and our Facebook page as well. The next item on the agenda is the presentation of certificate. And I will call on Dr. Safia Borodo to please present the certificate to Dr. Olive. So I will share the screen, then Dr. Safia will present the certificate of appreciation on behalf of Pharmacy Scholars Initiative. Dr. Safia, brother, if you are close, please.
Yes.
Yes, have you seen the slide?
Yes, I can see your slide.
All right.
I can see your screen.
All right.
This is the Pharmacy Scholars Initiative Certificate of Appreciation awarded to Olive Schmid, PhD, for her outstanding contribution as a special guest during the PSI quarterly webinar held on the 2nd of March 2024.
Thank you.
Dr. Olive.
My pleasure, Sophia.
Yeah, here's presenting the certificate to you.
I will print out. I will print out the certificate and put it on my wall.
All right. Oh,
Okay.
that would be lovely.
Thank you, Dr. Olive.
Sorry, before we go, could I just please check? Can we save the messages that people have typed, just because there's a couple of questions that we might be able to answer after the session when people have asked for things.
Okay, I've just seen one. It's a little bit lengthy. Okay. So this guy, Abdul Jabbar, he says he's currently studying online course on data science by IBM in Coursera platform. I would really appreciate if you can share the link where we can have access to the research you did, so we can have better insights at the detail of the step-by-step processes you followed to complete your research. So Olive, I think he's asking if you can have access to maybe your published papers or your thesis.
Yeah, I think we can arrange that, but if you
but your thesis is freely online. Can I share the slide?
I don't think the UTAS library have put it online yet.
It is.
Yeah, I don't think it's online yet.
Okay. Sorry, it's mine's already online. Sorry.
Yeah, I think it takes a year after graduation or something.
Oh, yes.
But yes, I will yeah, I'll see what we can
so I think Abdul Jabbar, what we'll do is, if you have filled the form where you provide your email and name, possibly when you receive your certificate and link to the recording, could you please ask this question by replying to the email? Then I will send you her published articles where you can have like an idea about what she's doing. And I'm not promising you, but when her thesis is freely online, we'll send it to your email. Is that okay, Olive?
Yeah, that sounds good. And just just to clarify, even though my thesis had a whole chapter on the data analysis that I did, it didn't go anything into the detail of step-by-step R code for different steps or anything like that. It was more an overview of how, rather than containing any actual analysis code.
Okay, anyway, if you have any question related to it, you can just reply to our email. Yes, the link has just been shared. So yeah, you can fill in your name and your email address. When you receive your webinar materials, then you can reply to the email requesting for this. Then if you have any specific question also, you can put it in the email and I'll pass it on to Olive.
Absolutely.
I think, we have taken a lot of time for our speaker. I'll call on Dr. Abubakar Bilyaminu to give the closing remark on behalf of Pharmacy Scholars Initiative. But before going then, Mustafa, do you have anything to add?
No, just to appreciate Dr. Olive for her time, and we look forward to collaborating and seeing each other in other workshops in the future. Sure.
Yes, definitely. We'll meet
so
on hands-on training. All right, Dr. Abubakar, I mean, if you are close, please give us the closing remarks.
Okay. Good afternoon, good morning, and good evening, everyone. So, on behalf of the Pharmacy Scholars Initiative and the organizing committee, I'm delighted to deliver these closing remarks on the success of our first webinar series for the year 2024. I believe that during this webinar, we have all had an insightful and interactive discussion on data science. I would like to thank our distinguished speaker in person of Dr. Olive Schmid, who have shared her valuable experience. And I would also like to thank our participants coming from all walks of science and different parts of the globe. So we do hope to see you in our future and subsequent webinars. Thank you, everyone. We wish you happy logging out. Thank you.
All right, thank you so much. Thank you so much. Olive, thank you so much. Really appreciate everyone. Bye-bye and good night from here.
Good night, good morning, good day.
Good night.